Okay, so this is part 3. We're going to be doing SPSS, and we're going to be seeing how the ANOVA stuff works in SPSS. So I've got 3 data sets. One is just going to be independent samples ANOVA. One of them is going to be the repeated measures ANOVA, and one of them is going to be a two-way ANOVA. We're going to see how to do everything we need to do here. All right, so starting off, we have the independent samples ANOVA, right? This is the very first example we did in the notes, right? We've got 3 different telephone conditions. They are, if we look in the notes here, right? This is the no phone versus handheld versus hands-free treatment conditions. And it's the same data. I just typed it into SPSS. So it's ready to go. What we're going to do to find ANOVA, right? And I'm just assuming that you already are good with SPSS, getting your data in, importing data, cleaning up your data, labeling things, giving it, labels, whatever, all that stuff. That's not what this lesson's about. So I'm assuming that you're all good for that, but you have your data, it's nice and clean, it's ready to analyze, and we go compare means, one-way ANOVA. That's going to be what we're doing for the independent ANOVA. For everything else, we're going to be in general linear model today. We're going to be doing repeated measures and univariate later. But for this one, it's one-way ANOVA. And now, when you first open this, it'll all start on the left, right? Everything's on the left to start with. But the dependent variable is going to be the score, right? And the factor is going to be the telephone conditions, right? No phone, handheld, or hands-free. We also want to add in a post hoc test, right? And so when you open this for the first time, everything's going to be blank, but you're going to check off the ones we know, Tukey and Chaffee, right? There's, of course, many more different post hoc tests. There's a lot of them, but the ones we learned are Tukey and Chaffee. All right, and we're going to click continue. In the options, right, we have some stuff that we don't really need to worry about. The homogeneity of variance test is something that that you might learn about when you do ANOVA sometimes. Right, I'll check that one off just to show you. Homogeneity of variance is a good thing and will make our ANOVAs more reliable. So, if we do this test and it comes out that we have homogeneous variance, that makes our results better. But it's not something we've learned in this class, so not a big deal right now. Anyway, that's all we really need to do, right? Dependent goes here, factor goes there, post hoc, check off the ones you want. And then we click OK, and we get some output. So the homogeneity of variances, this is good. We like to see big p-values here. If the p-values were small, it would mean that the variances were significantly different between the groups, and that would make the ANOVA less reliable, right? So big p-values is good to see here. Again, we didn't actually learn about this Levine test in class, so we're not going to worry about that too much. But I just wanted to, click on it and show you, because this is a thing that you might actually do in the real world. This is the important bit. This is the ANOVA table, and this is the table that we get in the notes, right? It's the exact same table, the exact same numbers, right? If we go here and we scroll down until we get to our table, we can see we got the 30 and the 16, the 2 and the 12, the 15 and the 1.33, and then the F is the 11.28. Is that the same one, or is that the other one? Hold on. Yeah, the 15 and the 1.33 and the 11 point. They're getting 11.28 because they didn't round, because they rounded. But the answer we're getting here is actually more precise, 11.25. That's the correct answer. Right, and then there's a p-value. So remember last term, I said, yeah, you can do the test statistic critical value method, but when you're using a computer, the easiest thing is to look at p-values. This p-value is smaller than 0.05, which is our alpha, or 0.01. Either way, this is smaller, right? And so what does that mean? That means that we reject the null hypothesis. That means there is a difference between the groups. Okay, and so doing that means we don't have to look up, what would be the critical value to compare this F to, right? We can just use the p-value and we're done. So that's the main ANOVA. We reject the null hypothesis. The type of phone, no phone versus handheld versus hands-free, does have an effect. Now, when we reject that null hypothesis, what do we want to do? We want to do a post hoc test, right? The Tukey or the Scheffé. And those are here, right? And so here we can look at the pairs and we can see there's a p-value. That's a small p-value. This is a significant difference. What does this correspond to? Well, if we look on this row, that's group 0 versus group 1. Right? So that's the no phone versus handheld. That is a significant difference. And then here, this is also significant. No phone versus hands-free is significant. Right? This one's also significant, which is but that's just 1 versus 0, which is the same as 0 versus 1. Right? But then this one is not significant. 1 versus 2. Right? 1 versus 2 is handheld versus hands-free. That's not significant. Right? And then these ones just repeat the same things again. 2 versus 0 is the same as 0 versus 2, and 2 versus 1 is the same as 1 versus 2. So every comparison is actually on here twice, which I know is a little bit weird, but that's just the way they do it, right? So the comparing 0 to 1 and 0 to 2, we get significant differences, but comparing 1 to 2, we get not significant. So in other words, there is a significant difference when you look at the no phone versus handheld, and also when you look at no phone versus hands-free. But there is not a significant difference in scores when you look at the handheld versus hands-free. That's what the Tukey test shows us. And then the Scheffé test shows us the same thing, right? The p-values are different, but we get the same results in terms of which pairs are significant and which pairs are not, right? 1 versus 2 is still not significant. The other ones are significant, right? Based on these p-values. Okay, so that's how we do these post hoc tests. All right, so that is our basic independent samples ANOVA. And now we've got to do the next data set here, which is my repeated measures ANOVA. So this is the one from the week 4 notes, which is right here, right? It's this example: reread, answer prepared questions versus create and answer questions, and we're seeing how what score they got on their reading comprehension test or whatever. And so I've replicated that data exactly here, right, with students A, B, C, D, E, and F. And so now what I want to do for repeated measures is I'm going to go to a different place. I'm going to go analyze, but it's not compare means anymore, where the one-way ANOVA was. It's not there. Now it's general linear model repeated measures. Okay, I'm just going to delete the stuff that's here because I want to do from scratch, right? So from scratch, what you get is you get this window here, right? Define factors. So the within subject factor name, I'm just going to call that mode, right? Like what mode were they using? Were they rereading? Were they answering prepared questions? Or were they creating and answering their own questions, right? So that's going to be the mode and there are 3 levels, right? Each person was tested 3 times. So it says number of levels, that's how many times did you test each person, right? Under how many different conditions. And then we're going to click add. And then we need a measure name, which I'm just going to call score, right? Because all of these are scores on their reading comprehension test or whatever. And then we're going to click define, right? Exactly what you name this doesn't really matter. The thing that matters most here is the number of levels, right? You need to make sure that that is the number of times you measured each person. So now we define, and now this should, I had already done this, so some stuff was already done. But when you get this to start with, what you should see is these, right? Blank, blank, and blank. What you're going to do is you're going to drag these over into group 1, group 2, and group 3. All right, there are no between subjects factors. There are no covariates. We just have the 1, 2, 3 levels, right? However many levels you have, you're dragging over those variables. Okay, so this is the main part. once this is done, clicking OK will get us the main thing. But I want to also show you how to get plots and how to get post hoc tests. So plots are here, right? So there's only one thing I can do, right? Put mode on the horizontal axis and click add, and that'll give me a little plot. So that'll be fun. And then post hoc, you might think we click here for post hoc, right? But no, everything is grayed out. There are no post hoc tests we can do here, but that's weird because we know we should be able to do post hoc tests, right? And the trick is here for whatever reason, SPSS is set up so that the post hoc tests are not here for these within subject variables. It would only be if you had a separate factor that was a between subjects factor that would show up here, but we don't have that. And we're not looking at that, right? That would be, that's a whole slightly more complicated thing, right? Because then you're getting into, doing a two-way ANOVA with repeated measures and so on. So don't worry about that. We're not doing that. Where we want to find the thing we need for post hoc tests is here, where it says EM means, right? And it's going to start off like this, but we're just going to take mode and we're going to say display means for mode and compare the main effects. And the adjustment we want to use is the Bonferroni is the standard one. So we can just use that. And then this is going to allow us to compare the effects on those means, which is going to be what we want. So we're going to click continue. And now we're going to click OK. Right? So there was nothing in post hoc. It was EM means where we had to go and move that over, move mode over as the factor we're comparing means for. And then we click OK and we get our stuff here. Right? So first of all, there's this like stuff we don't really know about yet, right? This like, what is Moschli's test of sphericity? We haven't learned that. It does have to do with, these sphericity assumed thing here, right? But let's not worry too much about that. We didn't learn about that, and that's a bit more advanced. What we'll notice though is that, hey, this 84 and the 2 and the 42 and the 22 and the 10 and the 2.2 and then the 19.091, those are the things we get over here when we get it by hand. When we did it by hand, right, we got the 84 and the 22, the 2 and the 10, the 42 and the 2.2, and then we divided to get the 19.09. That is the same thing we've got going on here, 19.09. Right, and our p-value is very small, right? Sphericity assumed is the default one. We're going to use that, in this course, we're just looking at that because we're not doing the advanced stuff, right? But even if we were doing the advanced stuff, all of these are significant, right? All of these are less than 0.05 or even less than 0.01, right? So even at a strong level of significance, it is still significant, right? So this means there is a difference, right? There is an effect. We reject the null hypothesis because our p-value is small. So then what we want to do is the post hoc stuff, right? So we've rejected the null hypothesis. Now we're going to do post hoc. Where is that? We scroll down, we scroll down, we scroll down, and here's the post hoc stuff, right? And we can see that 1 versus 2 is significant at 0.05, but not at 0.01. 1 versus 3 is significant at any level because it's very, very small p-value. And 2 versus 3 is not significant. Right? So we got here, what were our groups, right? They were 1 versus 2 was significant, 1 versus 3 was significant, 2 versus 3 was not significant, right? So rereading is significantly different than the other two, but the other two are not significantly different from each other. That was what we found by looking at these p-values, right? The one that is not significant is the 2 versus 3. Also the 3 versus 2, but that's the same thing, right? Remember, everything's here twice for whatever reason. Okay, so that's how we get our post hoc tests. And yeah, so that's it, right? And you'll notice here, this isn't like Chaffee versus Tukey. It's technically it's a Bonferroni, but that's just how this one goes in ANOVA. They don't let us do the Tukey and Chaffee here for whatever reason. SPSS just doesn't have that option. So we still got post hoc tests, which is what we want. And we can use these, right? In the real world, you just use these post hoc tests and they're good, right? These are the default ones that SPSS provides you because they are, they are good. They're the ones we would tend to want to see. And here's our little graph, right? I clicked on plots so I could get a plot, right? And you can see here, right? The 1 is very different from the 2 and the 3. The 2 and the 3 are not very different from each other. Okay, so that's repeated measures with the post hoc tests. The post hoc tests weren't exactly what we learned because it wasn't the Tukey and the Scheffé, but it is still post hoc tests. We can still use them. We can still interpret them. Right, so now we know how to use SPSS for the independent and the repeated measures ANOVAs. All that's left is the two-factor. And so for two-factor, I've got that going on here. Right, this is the one we just looked at in the other recording. Right, we have different scores based on 4 groups, right? The time control had 2 factors and the text mode had 2 factors. This was this example. All right, and I use the same data, so we should get the same numbers when we run this in SPSS. So where do we go for this one? Well, for this one, we go general linear model, and then not repeated measures this time. This time we're going to univariate. Let me put everything back the way it was, right? So to start with, everything would be here. Your dependent variable, which is the score, is going to be your dependent variable. And then the factors, factor A and factor B, are going to go under what they call fixed factors. These are not random factors. These are not covariates. These are fixed factors. Okay. What is a random factor? What is a covariate? That is more advanced than we are doing here. So we're not worried about those right now. We have fixed factors. So now what do we want to do? Well, if we want those graphs, we can go into plots, right? Plots, and then we can put one of these on the horizontal axis and then the other one on separate lines. So let's say time control can go on the horizontal axis and text mode goes on separate lines, and then we click add, and we'll get a line chart with that. And this is going to be that line chart we talked about in class in the recording there, where we want to see if the lines are parallel, right? That's going to be the thing we're looking at. What about post hoc? Here we can get post hoc tests. So post hoc tests for time control and for text mode, and we can do Scheffé and Tukey if we wanted. All right, so if we want post hoc, we can do those now. That is an option here. And you can see under options, they have all sorts of other stuff that we generally don't need to worry about. Right, a lot of more advanced stuff we can do here. Okay, but this should be fine, right? We have the 2 things in here. We have the plot we want. We have the post hoc test we want. We're going to click OK, and we get this result. So here's the big ANOVA table, and this one has more stuff than we got when we were doing it by hand. Basically, ignore the top 2 lines. Just start a time control, text mode, and then time control star text mode. That's the interaction, right? So we have like our factor A, factor B, and interaction. And these numbers are the same as we got when we were doing it over here, right? If we scroll down and we look at our actual table, we get the 11.25, the 11.25, and the 31.25, and the 3, right? Which gets us these Fs. Same thing here, right? 11.25, 11.25, 31.25, and 3, which gets us these Fs. And if you wanted to compare those to critical value, you could, but remember, we're doing it on the computer, so the easiest thing is to look at the p-value. So the p-value tells us that factor A, time control, was not significant. We do not reject the null hypothesis. Same for factor B, not significant, bigger than 0.05. We do not reject the null hypothesis. But the interaction, that was significant, right? So there is a significant interaction between time control and text mode. And we can see that in this graph we got as well, right? These lines are very not parallel, right? They're not only not parallel, they're really not parallel. they're totally different, right? So the effect that time control has if you're using a computer is totally different from the effect that time control has if you're using paper. All right, so in one case, the time control seems to make things make your score go up. In the other case, it makes it go down. Right, so that's why we got the time control overall was not significant because sometimes it makes it go up, sometimes it makes it go down. There's enough randomness in the data that we're not confident in our conclusion. We're not confident enough to say that there is an effect of time control overall. But then when you look at isolating it to the individual groups of text mode, now there's definitely an interaction going on there, right? And that's clear in the picture, and it's clear in our results here with this small p-value for the interaction, right? And then because these two were not significant, we don't need to do the post hoc tests. I know we clicked on the option saying we could do post hoc tests, but for factor A and factor B, but we don't need to, right? Because they're not significant anyway. Also, just if you're paying close attention, you might say, wait, Jim, why would we do post hoc tests for factor A if factor A only had two groups? And you're totally right. If you only have two groups in a factor, you don't need a post hoc test because if there's a difference and there are only two groups, that difference must be between those two groups, right? So if you only have two levels for a factor, you don't actually need the post hoc for that factor. There's no point. You either have a difference in the two levels or you don't, right? But if you had 3 or 4 levels and you had these multiple factors, then you could actually look at the post hoc test to see where the differences were, if there were differences in those factors. In this case, there are no differences in the factors, and there's only 2 levels per factor. So there's 2 reasons why we don't need to look at post hoc tests, right? And they don't, in fact, they don't even present them to us, right? If we scroll down, we see they're missing, right? They're missing because this was not significant and that was not significant, right? So there are no post hoc tests to be done. Okay, so that is our 2-factor ANOVA, right? We have our factor A, factor B, and intercept. We got a little graph here. That's how you do it. So now you know how to do all the ANOVA stuff we learned about so far in SPSS and how to interpret the SPSS results. So we'll end part 3 here, and I'll see you all on Monday for test review.